Hello, everyone. Thanks for joining today's webinar on our wild weather of the last few weeks. This is an adjunct to our series on inequitable climate, and we want to address the equity dimensions of our ongoing winter storms. Before addressing the main topic, I want to start with Stanford's land acknowledgement. Stanford sits on the ancestral land of the Muwekma Ohlone tribe. This land was and continues to be of great importance to the Ohlone people. Consistent with our values of community and inclusion, we have a responsibility to acknowledge, honor, and make visible the university's relationship to Native peoples. For today's webinar, what we're calling Whiplash Weather, Lessons from California's Deadly 2023 Storms, I'm thrilled to be joined by Noah Diffenbaugh, Rosemary Knight, Matt Robinson, and Jenny Sukali. I'm Chris Field, director of the Stanford Woods Institute for the Environment. The Woods Institute has been for nearly 20 years Stanford's marquee investment in advancing understanding and developing practical solutions to our era's pressing environmental problems. Woods Scholars team with other researchers, governments, companies, and NGOs to build bridges from research to action to address challenges in climate, health, food, water, oceans, and biodiversity. We're excited to be a founding pillar in the bold new Stanford Door School of Sustainability, which was officially launched last September 1st. Today's session is our first webinar of 2023, and it's part of our continuing exploration of climate-related extreme events and inequality. After today, the next event in this series will be on drought in March of 2023. Please check the Woods website for information on upcoming events related to climate and sustainability. I usually start these webinars with a little background, but that hardly feels necessary today. All of us have lived through the wild weather of the last few weeks, and we've seen firsthand the damage and human suffering that's occurred, and we all know about the tragic loss of life. We also know that rains sort of did and sort of did not end our historic drought. In today's session, we'll dive deep into the why of the storms, the what of the damage, and the how we can better manage future storms. For a perspective on understanding the weather we've seen over the last few weeks and managing its implications, I'm excited to be joined by 3 Stanford colleagues and a frontline county official from Sacramento County. Matt Robinson is the Public Information Manager for Sacramento County Department of Water Resources. He's been with the county since 2016. He's a spokesperson for Sacramento County during activation of Emergency Operations Center during the current flood emergency, and he was for the flood event in 2017. Matt also manages the department's outreach efforts for water conservation. He's been a public information officer since 2002, working for Stockton and Tracy as well as the state. Prior to that, Matt was a television and radio reporter for 15 years. Rosemary Knight is the George L. Harrington Professor in the Stanford Door School of Sustainability, Professor of Geophysics and Earth System Science, and a Senior Fellow at the Woods Institute. Her research group works on finding innovative ways of using geophysical methods to understand the hydrological processes occurring in the top kilometer of Earth. A current focus is the integration of geophysical imaging with remote sensing data for the evaluation and management of groundwater resources. These methods are key to recharging California's depleted aquifers. Jenny Sukali is an assistant professor of geophysics and center fellow at the Woods Institute for the Environment. Her group studies disasters to reduce the risks they pose. Her approach combines customized mathematical models with evaluation of community needs through scientific co-production. Jenny's group works on extremes across different natural systems to identify commonalities in the physical processes and the best practices for mitigating risk at the community level. Their current research priorities include volcanic eruptions, ice sheet instability, permafrost disintegration, induced earthquakes, and flood risk. Noah Diffenbaugh is the Cara J. Foundation Professor and Kimmelman Family Senior Fellow in the Door School of Sustainability, and he's also the Olivier Nomalini Family University Fellow in Undergraduate Education. Noah studies the climate system, including the processes by which climate change could impact agriculture, water resources, and human health. Noah's a leading expert on California climate and why we have extremes of both flood and drought. It's a very big public profile, including service as the inaugural editor-in-chief of the new journal, Environmental Research Climate, and editor-in-chief of Geophysical Research Letters. He's also active in explaining climate in the media and in congressional testimony. The format for the next segment of today's webinar is that I'll start with a few questions. After about 20 minutes, we'll get to what I always find to be the good part, questions from all of you in the audience. To get a question into the queue, type it at any time into the Q&A box using the little Q&A button at the bottom of your screen. We'll get to as many questions as we can. And after the conversation, we'll draft answers to any unanswered questions and post them on the Woods website. Let me start with the first question to Noah. We've seen historic rains over the last several weeks, but we really don't have a general sense of how this fits into the long scope of California's rainfall events. Are these hyper storms that are driven by climate change, or does this fit into the pattern of traditional variability? And what is unique about the rainfall events over the last several weeks?
Yeah, thanks. And it's great to be here as always. I think that, first and foremost, we've had for California, a large number of storms in short succession. Certainly having the same number of storms, each delivering the same amount of precipitation, but spread out over the course of several months rather than a few weeks would have, had been much less damaging from the perspective of the flooding and the debris flows and the other impacts that we've been experiencing. So I think we're going to see quite a bit of research on this event in the coming couple of years, and I think one of the major foci will be on, what are the odds of getting this particular succession of storms in close proximity in the current climate and in a historical climate. I think that the part that is clearly more unique is having a uniquely severe drought as the backdrop for these precipitation events, and that general setup is certainly predicted for California when I was in middle school, at least. So Peter Glick's work back in the 1980s. And then since then, it's been emerging in the historical record in terms of our actual observations. The climate's been becoming more like this in California, where protracted hot, dry conditions punctuated by extreme wet conditions have been becoming more likely, in a recent experience, increasingly the norm. So anecdotally, what we've had in the last decade has been a historic drought that was then interrupted by extremely wet conditions that were then followed by another historic drought that have then again been interrupted by extremely wet conditions.
And would it be fair to characterize the storms over the last month as not particularly exceptional on a storm by storm basis, but very unusual in the extent to which a whole bunch of storms lined up to hit us in rapid succession?
Yeah, so I think at the first order, I think like Mike Anderson, the state climatologist, has said that overall statewide, none of the storms has been particularly exceptional. I think locally, people living through them would probably I know anecdotally some have said, well, this is it hasn't rained like this in however long, or it hasn't snowed like this in however long. But I think at the first order, what's really caused the excess water and the problems we're having with excess water has been the rapid succession, and really that New Year's Eve storm we saw certainly flood a lot of space for flood control get filled up, and then we've had additional storms that have been coming on top of full reservoirs, and I'm not the expert on the reservoirs here, but I'll just note when I say that I mean some of the more local reservoirs that are in place for flood control, as opposed to our very large reservoirs that we rely on for water storage, which are still have a lot of capacity due to the drought.
And let me follow up with a question for Matt about why things have broken. And the sense I have is that that we basically kind of used up all of our resilience space for flood protection, and then the rains kept coming and pushed us into these damaging conditions that weren't so much a consequence of not having preparations in place, but not really having the resources to deal with the magnitude of these events.
Well, the water came at us, and the way it did was just in a fashion that was overwhelming, as everyone knows. For us in the Sacramento County region, we're in a floodplain. Everybody knows that. And unfortunately, what happens is when we get hit hard with a lot of rain, we end up having a situation where our aquifers and all of the lakes start to become overwhelmed. Being in a floodplain, we always warn people, starting October, you live in a floodplain, you need to be ready. The problem is that all of the attention has been given to the levee breaks and all of the water that came from the Cosumnes River, when in fact, we're always seeing flooding during heavy rains in neighborhood areas as well. And so, when we see the big, huge torrential floods and rain that come our way and that captures everyone's attention, I always sit there and go, well, what about the other years? Back in 2021, we had a storm system that came through in October that dumped a historical amount of water in our area. And it was a situation where it came quickly and left. So, people know that it can happen at any time. Now, compound that with the fact that this was on the heels of drought. A lot of times for me as a public information officer, the person has to talk to the residents and get them educated about this. It can be tough trying to get people to remember you live in a floodplain. And so when we do have situations like this where the water comes at us all at once, at first people are surprised, and then they get back into the mode of, okay, this could flood and I need to be ready. So when you have so much coming at us at once, there's that instant panic, but then people slide into the norm of, okay, I need to make sure that my family's safe and all of that. And, unfortunately, we had a situation where the water came upon us in a fashion that actually isn't unique for this area. When I was a reporter in '97 in Sacramento, same thing happened. We had a huge flood event. We had Highway 99, I-5 cut off. And so the residents living in this area who've been around for 30, 40 years, possibly 2 generations, they know they're in a flood event. But like I said before, couple that with the fact that we're coming off a drought, people tend to forget. And so they kind of get a little lackadaisical on that. And we just want to make sure that, at least in our area, that the public keeps well versed on the fact that they're in a floodplain.
Super important starting message. And one of the things that I'm hoping we will transition to as this conversation moves along is more and more comments about what we can do to be as well prepared as possible and to make sure that when the events that you expect in a floodplain do occur, that they're not leading to excessive loss of life and damage. And Jenny, I know this is the topic that you really focus on, and I wonder from the perspective of a scholar who thinks about community responses to extreme events, where you see the system working well and where you see opportunities for doing better in the future.
Yeah, thanks for thinking of communities and the path forward. I definitely think there is some problems inherent to how we typically manage flood risk, and that starts at a pretty basic level of focusing on one single design event in our planning. So a lot of planning efforts choose one design event and then try to mitigate the risks for that particular event. The drawbacks of that is that 2 floods don't tend to be alike. There's various reasons for that. Sometimes there's more ocean contribution or less ocean contribution. Sometimes there's multiple floods in succession. So I think of each flood as being quite unique. And so there isn't really a thing like a 100-year flood. There's really many possible floods that could have a typical return period like that. And I think that insight becomes particularly important as climate continues to change and the variability goes up. So what was a 100-year flood in the past, say pre-1970, might no longer be a 100-year flood, but could be a 50-year flood, could even be shorter than that. So I think what we're currently working on towards with our partners in the public sector. So we're working with the San Francisco Creek Joint Powers Authority. We're working with the city, with the county, with other stakeholders, also at the California state level, is try to think more about how to adjust to a whole spectrum of possible floods and maybe have a plan A, a plan B, and a plan C, depending on what's going to hit us. And I think there's huge value in that. Also, we're thinking very specifically about how specific infrastructure interventions benefit some communities, but maybe not necessarily all communities, to make sure that we're ultimately serving everybody's needs. So I do think there is a lot of innovative thinking happening. And hopefully we will get better at this. But I do think that the way of approaching these problems in the same way as we've done in the past is not longer going to serve us particularly well.
Yeah, thanks. I do want to swing back to the plan A, plan B, plan C, and the equity dimensions in a minute. But first, I want to ask Rosemary, who works on what you do with all this water when you have it, whether aquifer recharge is a technology that can help with the flooding, or whether we should really think about aquifer recharge as something that provides access to water resources during the extended periods between the floods.
Well, the answer is both. I look at it as we can use aquifer recharge in both ways. So there's tremendous benefit to us thinking more about how do we recharge? How do we refill the groundwater systems of California? After many, many years of pumping so much water, there's a lot of space. Water levels are down. So going back to Jenny's comment that going forward, I think we have to think very differently than we have in the past. We very much focused on the engineered infrastructure that we have in California. Our reservoirs, our dams, our aqueducts, our irrigation canals, everywhere, moving surface water around, managing surface water. I think it's time to really tap into the natural infrastructure that we have below the ground surface and think creatively about how to integrate the above ground engineered infrastructure with the below ground natural infrastructure. Below the ground surface, I pulled some facts out. Because we have lowered the water levels, there's 140 million acre feet of space. Now, 140 million acre feet, acre foot, acre, add a foot of water. So we very quickly have defined a new unit of measure for groundwater. The space available underground equals 30 Lake Shastas. So that gives you a feel for how much empty space is below the ground surface. For comparison, the total surface storage capacity in California, so the engineered infrastructure, is 9 Lake Shastas. So our natural infrastructure can provide us 3 times as much storage as our engineered infrastructure. So returning to Noah's point and coming around to more specifically answer your question, Chris, this pattern of extreme droughts followed by extreme floods is likely to be closer to the norm going forward than we might like to think. Yeah. So therefore, we could use the floods to recover from and prepare for the droughts by capturing much of the flood water and using it, getting it underground, moving it quickly. Don't let our reservoirs fill up, but moving it quickly to surface sites where we can get it down below the ground and use that storage to give us groundwater for our next drought.
And can I ask a quick follow-up on that? My impression is that there are some places where it's sort of easy to get the floodwater into the aquifer, and many places where it's not easy at all. And I think of it as like there's some kind of a big valve between the flood part and the aquifer part. And is that valve big enough that if we were really smart about the way we opened it, we could actually decrease the water flow in the Cosumnes River that's been flooding in Sacramento County, or is the size of the valve a fundamental constraint?
Well, I think we need lots of valves. So I think what we need to be doing is taking water and distributing it to locations on the ground surface that are optimal for recharge. So finding locations, one of the solutions is restoration of floodplains. So let nature go back to doing what nature used to do, more floodplains, not where people are living on the floodplains, but where we have floodplains now that are there to absorb floodwater, provide wildlife habitat. Other places where we designate, I'm a big fan of zoning for recharge. So we look at our land surface, we look at our land use, and we say, here's a place where we could direct floodwater, and the properties at the surface and below the surface are such that we're going to rapidly move water underground and move it deeper within the groundwater system. So you're unlikely to find one location where you can open the valve, Chris, and all the water is gone. But we can think of a subsurface natural infrastructure that we can tap into by moving floodwater to specific locations on the ground surface. And do you want to know how to find them? That's a later question. Geophysics.
Let me swing back to Noah. I want to follow up on Jenny's comment about every flood is kind of different, and they're different in terms of their impacts as well as their temporal and spatial dimensions. We've heard a lot about these floods being related to atmospheric rivers, and I wonder if you can paint a picture of what it means to have an atmospheric river and the implications of that for event to event differences.
Yeah, so that the atmospheric rivers they've been on planet Earth longer than they've been called atmospheric rivers, but they're a fundamental feature of the climate system, and really one of the primary ways in which moisture is transported from the tropics and subtropics poleward through the atmosphere. They were identified as atmospheric rivers in the 80s and 90s, and it's the way we get most of our precipitation here in California is in these atmospheric rivers, and really that the number of atmospheric rivers is a pretty good metric of whether we have a dry year, a normal year, or a wet year, and it doesn't take it's kind of one handful, two handfuls, three handfuls, basically, in those categories. So, that's sort of the fundamental feature of our precipitation. How they're spread out, as I was saying earlier, matters a lot for whether we're getting just sort of an even distribution of precipitation, or if we're getting a lot at once, like we've had, and frankly, like we had last year. We started out with a really healthy early precipitation and snowpack, and then the proverbial tap was turned off, and we had a phenomenally dry January, February, and March last year, and ended up really in continuing with protracted drought. So I think that in terms of what's changing, what we know that's changing, we know that the atmospheric rivers that make landfall along the Pacific coast in general are getting warmer. We know that that the rain snow line is going up in elevation. We also know that the flood risk in terms of runoff in streams increases exponentially as the rain percentage goes up, and so for our existing water system, the changes are pushing in the direction towards greater risk, in terms of decreasing reliability of snowpack, greater likelihood of liquid precipitation rather than solid precipitation at lower elevation, earlier melting of the snow that is on the ground, and that gets to Jenny's point about floods being different, right? Like what's the rain on snow is very different than the rain by itself. So and then I think what we were hearing from Rosemary about how we manage flood risk from an infrastructure point of view, we really do use the same engineered infrastructure for both flood control and water storage, and that creates a lot of pressure, even in the old climate that it was designed in. But certainly with climate change, the pressure's going up. I think we have clear evidence of that.
And when you think about where climate science, especially climate change science, is helping us with predicting the future, is it better to think about the kinds of general conclusions that you've talked about? More variability, extended droughts, concentrated rain, or are we moving toward a period where we might expect accurate seasonal or even multi-year forecasts of how much rain there'll be and when it might come?
Yeah, so I think we're certainly starting to see multi-year forecasts of global temperature that are pretty reliable. At the AGU fall meeting, Francis Davenport, who's a alum here and postdoc with Libby Barnes at Colorado State now, Francis had a talk at AGU about the spatial pattern of multi-year forecasts for temperature at the scale of warmer or cooler or similar. So I think I've got a lot of confidence in them. That's all for temperature. I think the precipitation for the getting past the spring barrier for ENSO and into multi-year spatially resolved precipitation forecast, I think is going to continue to really push the limits of the inherent predictability of the climate system. We're in an era right now, you asked about climate science, so we're in an era now where artificial intelligence and machine learning in particular are creating a lot of optimism around advancing predictions. And I do think we have seen, I think we'll continue to see a boost from that. But I had a sentence once in a paper that was rejected in the abstract that said something like our ability to predict regional climate will not exceed the inherent predictability of the climate system. And it was rejected, and the reason was that the conclusion was tautological at best. So I still think it's true even if it's not useful.
That's probably your only paper that was ever rejected.
No, it was one of many.
Matt, when you think about the information that you want to provide people with about what it means to live in a floodplain and what they should expect in terms of precipitation, how do you think about the information that's coming from climate change science, especially about the prospect of being in a regime with higher variability and the dry periods concentrated and the wet periods concentrated?
Well, one of the things we try to do is to make sure that everyone is educated about where they live. Now, what Rosemary and Jenny were talking about with each flood being different is true. There's another factor to also consider, and that is exactly, I'm just going to go from the Sacramento area. We've had floods in 82, 86, 97, 17, and now in 2023. The one factor that has changed isn't from where the water's coming from, it's where the water's hitting. Back in 86, the area around Elk Grove was farmland, and so we had I-5, 99 cut across and it was cut off, but you didn't have homes there. Now you have homes, and the population ends up causing an issue that we have to deal with, because when homes are built, levees are built, and the water path is changed. If you look at some of the flooding video from the 1940s, totally different as today. One of the things we have to worry about is, where are the homes? Where have they been built? What changes have been made to the landscape that's going to cause where the water will go to? It's difficult for us to constantly tell people you're in a floodplain when they bought a house in a floodplain. And so, people think it's safe because we've had years of drought. Nothing's happened, people forget. And so every year we have this situation where we are constantly educating people starting in October. And we do it basically because of FEMA. We are a part of FEMA's emergency, basically it's called the community rating system. And so for people who live in a floodplain, they have to pay for flood insurance. And so what the county does is, being a part of the CRS, we do certain things, including educating the public, making sure our levees are okay. And that helps FEMA decide, okay, the residents in this area, they'll get up to 40% off their flood insurance. And flood insurance is very expensive. So we always have to make sure that we know exactly where the water's coming from, where the homes are, and just constantly changing of if we have a bad situation, how do we get the people out?
Yeah, I mean, this issue of how communities perceive and respond to flood risks is a really, really general one. And when you think about looking at the communities you work with, there are some things you can do that are based on information, some things are based on improving infrastructure, and some are based on zoning decisions about what gets built where. How do you think about deploying all those different modes of action, making California safer in the future?
Yeah, I think one important thing where I see opportunities for improvement is to get to a better assessment of the actual risk. So as was pointed out in the chat and some of the questions, there are issues around some of the flood mitigation infrastructure being accredited and some not. However, a dam tends to protect communities whether it is formally accredited or not. So sometimes there are communities where the dam is not considered in the flood maps because it's not formally accredited. But that means that the flood maps actually might show a higher risk than this community actually faces. There's also the opposite, where some of the flood maps suggest that a specific area is not prone to flooding, where we've seen flooding in the past. And there's a variety of communities that we work with to understand where that flooding is coming from. We don't often integrate different flood sources. So for example, some communities are actually seeing backflow from the ocean more commonly than flood maps predict currently. So I think it's important when we attempt to mitigate flood risk is to be transparent and clear in what this flood risk is. And I think there definitely is some opportunity for improvement there. I think there's also opportunity for improvement in terms of how we can respond to flood risk. And that can be simple things like focusing on removing trees from bridges where they can create flooding that might be unexpected just because they create a barrier, but also supporting communities after floods and really understanding what their needs are and not assuming that everybody's insured, not just relying exclusively on insurance, but trying to make sure that we understand the different needs of different community members and actually meet them.
Let me ask a couple of questions about what individuals and communities can do. And Rosemary, let me start by following up on your comments about aquifer recharge. Are there things that homeowners and individual farmers can do that facilitate aquifer recharge and decrease flood risk at the same time?
In California, I've been talking a lot about recharge and finding sites where we can move that water below the ground surface. Well, agriculture uses a lot of water in the Central Valley of California. So agriculture has been pumping the groundwater down. So we now have this space available. And what we're starting to see happen, and this is work that Helen Dahlke at UC Davis is one of the leaders on, is this concept, managed aquifer recharge. Everyone says MAR. So capturing floodwater, getting it underground, flood MAR. So floodwater managed aquifer recharge. Helen works on AgMAR, and I've also started working, where we use agricultural fields for managed aquifer recharge. So growers are starting to say there's times of the year when it's not going to damage what I'm doing with my fields for you to use this land, divert floodwater into these locations and get it below the ground surface. So where the work that I'm doing with my research group comes in is a grower is not going to volunteer their land for that purpose if the flooding of the land is going to damage their crops. And a specific example, a lot of enthusiasm among almond growers to flood the almond groves and let the water percolate down and fill up the groundwater system. But you don't want to flood an almond grove and have the water stay there and the storm continues and the winds come up, the almond trees would blow over. So the work we do is to use a geophysical imaging method to drive below between the rows of almond trees and see, given the properties of the subsurface here, is this a place where I can flood and the water is going to very quickly move down and move out and fill other parts of the groundwater system. So growers are really starting to say, hey, we want to be part of the solution. Use our land, divert the floodwater to our land, use that to fill up the groundwater, because they clearly see an opportunity there to use their land during the wet season to give more water availability during the growing season.
And I wonder if you can comment on whether this aquifer recharge as a component of our flood risk management strategy is catching on, and that you're hearing everything from individual homeowners to large growers wanting to be a part of the program. Matt, is that one was for you?
Yeah, I was thinking about that. I mean, you know, we go out there with the intent of dealing with homeowners in our area. You know, when it comes to the agricultural side, they are, you know, pretty much coming to us when they need something instead of us reaching out to them, outside of letting them know they live in a floodplain. In terms of any scientific effort, I'm not sure of what they're taking part of. It sounds good. You know, we're open to anything that's going to help protect our water system. You know, it's one of those situations where can we keep our water? And for example, the Sacramento County Water Agency has a conjunctive use effort through our water system where we do use groundwater and surface water. And since we've been in the drought, we have been tapping our groundwater system. And it's nice to see it being refilled now through these floodwaters. But, you know, in terms of the farming aspect, you know, it's more about how, for example, the farmers want to reach out and look for help.
Yeah, great. Thank you. I'm going to ask one more question and then start to ask questions from the audience. So if you have not yet gotten your question into the queue, now is a perfect opportunity to do this. No, I wanted to ask you about how to think about what aspects of the drought are ended, what aspects are ending, and what aspects are certain to persist almost no matter what happens in terms of the rainfall that we see for the rest of this season.
Yeah, so I think that you know, punctuation mark at the end is really important. The uncertainty about, you know, what happens for the rest of the season. I'm sure lots of viewers saw the news from the drought monitor last Thursday. We'll see what happens tomorrow morning, but you know, a lot of the state was downgraded from extreme to severe drought when the drought monitor came out last week. And we've seen the reservoirs, you know, I've had a tab open, you know, for the last 3 weeks that I'm refreshing every day for the reservoir status from the state of California. And I mean, the reservoirs have really gone up, the main water supply reservoirs statewide. And so, you know, I think that the historic, you know, if we think about the depth of the drought, you know, I think that the historic nature of that, you know, has, I guess I'll go on record here saying that's probably ended. That being said, you know, that doesn't mean the drought's over. And, you know, I think one of the questions is in the current climate, you know, does getting back to historical average mean that you've broken the drought? And, you know, I think if we looked at, for the most part, statewide, if we look at the reservoirs now, you know, they're really in a much healthier place than they were before Christmas. The snowpack certainly is you know, in some places twice the normal for the year and even above what we average on April 1st. So I think if we took a snapshot now, we might say, well, the drought, we're not in drought, but that, of course, droughts are cumulative, and so I don't think we're going to see that we're out of a state of water deficit, in the near term. And one way to think about this, is a pretty simple analogy. Just we're all used to a bank account of some sort, and the deficits accumulate, and it takes a lot to make up for a historic deficit. And I guess the place the analogy breaks down is if you get repaid all at once in your bank account can handle that. If we get repaid all at once with enough water to break this drought all at once, we're living with what the issues we have with that in terms of dealing with all that water.
And just like lottery winners often struggle with their newfound wealth, their California residents are struggling with their newfound water wealth, perhaps.
Yeah, absolutely.
Let me start with audience questions, and I start with Jenny. This is a question from Craig Patterson, and it concerns the implications of land change and how much that contributes to the droughts. The question is, if the forests are gone, then the soil goes, and there's nothing to hold the water in the aquifers. It's all connected. Is land use change playing a role in the damages that we're seeing in California?
I mean, I would argue as a physicist who works in an area that's called nonlinear systems, I think everything tends to play a role. I think it does matter whether a tree is there. It does matter whether we have healthy vegetation. We have profoundly changed the ecosystems around us here in the Bay Area. We've basically dried out, what used to be a marshland. So that definitely changes. There's no doubt about it. We do have trees being uprooted because they don't have a lot of vegetation around them anymore. We do see, a lot of landslides. That is also one factor where vegetation can play a huge role. We work on nature-based solutions, and I think nature-based solutions definitely, I think, are a really important component of any flood risk mitigation portfolio in a changing climate. That being said, they're not a magical answer either. So, for example, if you are already thinking about flood risk along an urban river, where you have houses side by side to the river banks, like, for example, San Francisco Creek here in the area would be, it's not so easy to make space for the river, right? Like, I think it's a great idea in principle, and I think we should adopt it where we can. But I think we also need to look at other options. I think it's valuable to keep in mind that we fundamentally changed the hydrology in this area. And I think it's not so easy to just go back to what it was before. We have a lot of people living, and sometimes, there is a bit this attitude that, okay, well, the flood will happen and we just have to deal with it. But we should think about who we put that burden on. And I think a lot of communities, particularly here in the area, are not ready to shoulder yet an additional burden. We work with many householders who are already really stretched thin by many of the demands of the recent years. And I think we need to think carefully about how we can take this on as a community, with nature playing an important role, but also being realistic in what we can achieve and who will pay the price for that, and also in honoring, I think, the achievements that engineering have brought. So I think a blend of an engineering-based approach and a natural-based approach is where I see the greatest opportunities.
And of course, when we think about consequences of land surface change, it's important to recognize that there's a very strong link between recent wildfire activity and risk of debris flows. And we lucked out in terms of having a relatively modest wildfire year in 2022, but certainly we have a legacy of very big wildfire years and are looking at big wildfire risk in the future with really challenging consequences for flood management and debris flows especially. Noah, this question from Barry Thornton that says, what are the factors that influence whether the storms bunch up and come in quick succession?
Yeah, I think we're going to see a lot of papers on that, and maybe even like a special issue of a journal or something. I do want to highlight something that Dimitri put in the chat about this being, happening in a La Nina year, and there being a tendency to think of California as dry during La Nina and wet during El Ninos, and that, of course, is not actually the case in terms of California's history, both in terms of when we've had wet and dry events, and also just with the statistics and the dynamics. And so I think that this event is going to be studied, partly because it's California, but also partly because of the particular configuration. I think understanding what it is that, quote, opened the storm door in this particular configuration, I think is going to be an important question. And I think it's certainly a feature of the variability of California that we are right at the transition point of the canonical teleconnections for ENSO, and that means that we really do get quite a bit of exception to that canonical teleconnection.
Terrific. Yeah, I really I struggle with how to think about presenting the most useful climate information. Amazing amount of new research available, but really hard to channel it in ways that provide the kinds of forecasts that drought managers and flood managers can really take immediate advantage of. And it means that a lot of the emphasis needs to shift to the kind of long-term thinking that Annie emphasizes and the community information that Matt emphasizes.
Yeah, and I think the forecasts have been good for me as I have a lot of family in the area, and I've been refreshing the public forecasts, and in addition to Daniel Swain's tweets, but the National Weather Service and Climate Prediction Center stream forecasts, and in addition to the precipitation forecasts. And I think it hasn't been a surprise that these, at least on the synoptic timescale, on the multi-day timescale, that more atmospheric rivers were on their way. And I see, I'll yield to Yenny, but I think that I think part of the challenge is how to communicate that we do need resilience in order to be prepared when the accurate short-term forecasts arrive.
Mm-hmm. Mm-hmm. Yenny, comment on this?
Yeah, I just want to briefly comment on this. I think there are two problems here. I think there is one problem regarding how accurate our forecast is, and then I think there's another problem about how much we rely on the forecast being accurate. And I think there's a big risk in pretending that the forecast is going to be accurate when it's not going to be. And so we've looked at this only for the flood risk, but even when you compare a couple of recent floods for some rivers to the flood maps that are out there, flood risk maps that are out there, they're not a good match. And so I think as a science community, I think it would be valuable to think more about how we can build more adaptivity into the systems. I think it's going to be challenging to be very accurate. And I think there's an inherent risk in promising accuracy if we are dealing with a constantly evolving climate and with a lot of uncertainty in how these extreme events occur in different years. So I think there is a great value in not just emphasizing forecast and forecastability, but also problem solving ability. I personally think there's a lot that science can contribute in terms of problem solving ability in a framework that takes into account the uncertainty, which is just here to stay. And I think I think we need partnerships. So we need to understand how planners are currently approaching this, and then think about what kind of science we can co-produce together. But I just want to mention that I think there's been a lot of questions also in the chat about the accuracy of forecasts, and these things are very hard to forecast. And I think that's important to keep in mind.
Matt, you've spoken a lot about the importance of people just being aware that they live in a floodplain and that flooding is something they need to be prepared for?
Well,
Where should we go beyond that?
Yeah, and when we're talking about the forecast, everyone watches the TV news, watches the weather. For the past 2 weeks, I've been in meetings every day with our emergency operations center, and in that we've had the National Weather Service. They readily admit that they're accurate 3 days, in 72 hours. Their 5-day forecast, a 10-day forecast. One of the things that they've been working on is trying to show us, at least from the county perspective, how confident they are in terms of their forecasting. And they will, as the days go forward towards a specific date of when we expect the rain to come, their forecasts and their confidence will improve. And they readily admit, they are working at trying to be more accurate. One of the issues that we found was in this recent rain, the wind that came through. And in a postmortem, so to speak, with the National Weather Service the next day when we had the huge wind event, one of the meteorologists told us they didn't realize it would be that strong. Meteorology is a tough business, and trying to forecast something that can change at a drop of a dime is really difficult. And how do you then turn around and tell the general public, get ready for flooding, get ready to evacuate when we're not as confident as, the information we're getting? That's the tough thing that we have to deal with.
Yeah, really tough issue. Let me ask one final question to Rosemary, and then I'm going to give everybody 30 seconds for a final closing thought. Rosemary, here's a question from Suzanne Riddell, and she says, how much has aquifer recharge been compromised by subsidence due to historic overpumping?
Oh, that's an interesting question. I was sitting here thinking about subsidence and flood risk, so I'm going to say something about that first. Matt, there are areas that you're talking about that are now flooded. And if you look at the subsidence maps, which we can get from INSAR data, there has been subsidence over the last 10 years in those areas. So flood maps, probably need some updating, thinking about subsidence through pumping of groundwater. So this subsidence that occurs, much of it is elastic. So the ground surface goes down because when we pull out groundwater, we reduce the pressure down there and materials compact, the ground surface subsides. Sometimes it comes back when we put the water back, but there is some that's irreversible. So we've looked at the amount of irreversible compaction in the aquifers. And even though it's scientifically super interesting in terms of doing the math as to how much space there is, it's not had a significant impact. And I do want to make an announcement here because someone sent me a question about my estimate of the amount of space available. I didn't do it. The Nature Conservancy did it, a 2016 report. So the space they have available, which I think I said was 30 Lake Shastas, not a significant impact. The impact of this permanent compaction would be in the decimal points.
Great. Thank you so much. Let me turn to each of the panelists for a final thought. In particular, what's the answer to the question that I should have asked but didn't get to? No, you want to start?
Yeah, I guess I've come off as the prediction optimist here. I'll say I lived in the Midwest for 5 years, and getting 3 days of warning because you can see the storm coming across the Pacific, I think is pretty luxurious. So, I think it's a big challenge. I agree with what everyone said about the challenge. I think that we are there are real limits of our abilities to know the future, and I really agree with what was said that where we can really take action is on our systems and practices and implementation for being prepared. And as Jenny said, that's going to take more co-production between scholars, scientists and engineers and communities. I do think that we do have a lot of information and we do have a lot of warning on the timescales where people at least can get to safety. Not necessarily move their houses and avoid a lot of catastrophic damage, but at least to get to safety. And I think one challenge that we continue to face, not just with these kinds of events, but with lots of different extreme events that are changing in the context of global warming, is how we create communication systems, warning systems that are to keep people safe that are, small c conservative and in a way that people are still willing to abide by them. And that's been a challenge for a very long time. And I think it certainly is, elevated in this context.
Thank you. Jenny, a closing thought?
Yeah, I think one closing thought maybe that I want to throw in. I feel like there's been a lot of questions in discussion in the chat about infrastructure but also nature-based solutions. I think we've covered those two pieces. I think the other piece that I think maybe we should think a little bit more about in the future is also the policy side of this when it comes to insurance or maybe community-based insurance approaches. I think we are realistically going to look at a lot more extremes in California, be it drought, be it fire, be it flood. So we have a challenge that goes beyond a specific event. And I think it would be really exciting to think a little bit more creatively about how we can, as a community, get ready for that kind of whiplash of different challenges and different extremes that we might not be anticipating in their very detail. But that I think we need to get ready for in general. So I think the policy side and insurance side of it, I think there's a lot of opportunity for improvement.
Thank you. Rosemary, what else should we be thinking about?
Picking up on the policy side, so building on Noah's optimism for prediction. If we can get predictions, people should be ready to go, ready to recharge. So what we need to do collectively, partnerships between academia, state agencies, communities, is identify the optimal sites for recharge. And we need to think about how to streamline the regulatory process so that you're not applying for a recharge site that you're going to use in 160 days. You're going to recharge there tomorrow. So we need to somehow figure out how to streamline the whole regulatory process for permitting recharge. Basically, no, I'm going to have 3 days, so I need 3 days notice to work through the paperwork. So really, let's get ready. Let's figure out where these recharge sites are. Let's come up with a map of California that shows optimal recharge sites and do what we need to do in terms of integrating our natural infrastructure with our engineering infrastructure and the regulatory framework.
Yeah, thank you. And Matt, let me give you the last word on this from the context of a sunny day, looking back on a really extreme event.
Mm-hmm. Well, one of the things I really would like to think about is, we have a lot of thought being put into this. We have a lot of research. How do we take all of that and turn it into action? Because everything that can be created, every idea that can be thought of, at some point, Joe and Jane neighborhood have to understand what's going on and then take it to the heart and do what needs to be done to, whether it's evacuate or to change their mindset in a drought situation. It's just one of those things of how do we take what's being done at such a high level and turn it into a neighborhood and say, this is what you need to do, and have them do it.
Yeah, that's fabulous. And thank you again to Noah and Matt and Jenny and Rosemary. Thanks to everybody in the audience. For me, the real take home from this event is that we are looking at a changing climate. We also are looking at a region that historically has transitioned between drought and heavy precipitation. As Matt said, many of us live in floodplains, and we have the resources, and in many cases, we have the understanding to make our preparation much better and to do a much better job of combining capabilities for recharging aquifers with decreasing flood risks. It's been a fascinating conversation. All of you were incredibly helpful in orienting my thinking about the events we've seen. So thank you so much. I also want to thank the superb Woods Institute staff that supported this event, especially Lee Rosenbaum, Kamaya Daniels, Molly Field, Roberta Tugendreich, Sue Daniels, and Christine Blank. And thanks to Evan Schwartz for video support. Thanks to everyone in the audience for joining today and for some spectacularly insightful questions.